Hey everyone, QUATRO here, and today I'm going to be explaining how Turbosmooth works inside 3ds Max. Well, first of all, I'm going to show you a quick PowerPoint presentation to explain the technical stuff that goes behind it, and then later on we'll move on to 3ds Max and I'll show you how to apply it and how it actually works inside it. So, let's get started. First of all, what is Turbosmooth? Well, it's as simple as that. It's a modifier in 3ds Max. Well, basically there are equivalents available in other 3D apps. I know Blender has it, Maya has it, so literally everything I explain you here can be transferred to, say, Maya, Blender, or Cinema 4D. So don't get scared if you don't know 3ds Max. Secondly, it's a mesh subdivision and smoothing algorithm. It works on NURBS, curves, and I'll explain it to you a little bit later. Basically, it's also a tool you'll be using for realistic high poly modeling. Since I'm doing that, I don't spend a day without using it, literally. And it's also a newer and faster version of Mesh Smooth. Older 3ds Max versions had Mesh Smooth, they had subdivision for surface, and Turbosmooth is essentially a faster version of that with, of course, fewer options. So how does it work? In plain words, it takes vertices of a mesh and treats them as non-uniform rational B-spline curve points and then subdivides the mesh to appeal the newly formed curvature. So basically, this black line represents a mesh, right? It represents a mesh flow, say a plane bent in a certain way, and these green dots are vertices. So basically what happens is, when applied, Turbosmooth algorithm actually takes into consideration these points and smooths them out. It kinda interpolates between them to make a nice even curve instead of a bunch of square points, whatever. So here are some examples. This is a model of a revolver I did recently, and this is how it actually looks. It's not meant to look that way, it's meant to be turbosmooth. So if you can compare these two images, this is the plain model I did, and I did it in a fashion so I could turbosmooth it later on. And as you can see, it's all very blocky with sharp angles and very squarey and stuff. And when smooth, you can actually see the nice curves it generates, and you can see that this blocky thing here actually appears really round there, and the handle here has some nasty angles and it all smooths out. So this is the kind of realism you can achieve with Mesh Smooth or Turbosmooth. And not only that, but it actually adds, it doesn't only smooth the model visually, but it also adds a lot more geometry, so you gotta be careful. This is the original wireframe and this is the smooth wireframe I used for the previous example. So basically, this is what you see, but this is what you actually get. You get a lot more polygons, and if you bump Turbosmooth iterations too high, you might end up with millions of polygons and your system could choke. So basically, you need to understand how Turbosmooth actually works before you can use it. Turbosmooth is not something you apply to a mesh right away, because you have to prepare the mesh first. Say we have a cube with 4 segments for each side, right? If I applied a Turbosmooth with a generous amount of iterations, so it happens, it interpolates everything really smoothly. What would happen is, it would take these 3 vertices here. There's a vertex here, vertex here, and vertex here. Imagine this is a cube with 4 iterations. So basically, it would take these 2 edges or 3 vertices and interpolate between them and generate this smooth transition. So, and that would happen not only on that side, but it would happen all over the model. So basically, instead of a cube, you would end up with a ball. And let's say we add more iterations for that cube. before smoothing it. So now we would actually end up with smoothing just the corners here, and it would look a little bit more like play dice or something like that. So this is something to be aware of. You need to add detail to appeal the Turbosmooth algorithm in order to achieve desired effects. So why should we use Turbosmooth? Basically it makes your objects exceptionally smooth and realistic if used properly. And it will also allow edges and corners of your object to catch highlights. Basically, in real life, no object has perfectly sharp corners. Take a bottle cap, a fork, a knife even, for example, or a milk carton, whatever, anything you can think of. Take it and just look at the edges. You'll see that they're actually a little bit round everywhere. And you would also see that those edges actually catch highlights when you align them with the lighting conditions that you have. And this is exactly what I showed you in one of my examples. This original model has perfect sharp 90-degree angles, and they don't look that good. And when I smooth it out, I actually get highlights here. I don't know if you can see it. I get highlights here. I get highlights all over this. I get highlights here. I get highlights there in that edge. I get highlights on that edge, which otherwise looks very flat when it's smooth. So basically this is what happens when you smooth it. And if you use correctly, of course, you can reach that another level of realism that you would want from a photorealistic rendering. So, and it's also easier to edit a low poly mesh and have a Turbosmooth on top of it than actually having to deal with a high poly model on its own. You know, like instead of moving just 3 polygons and letting Turbosmooth do all the rest, you would have to like move 300 polygons on their own with, say, soft selection or whatever. This wouldn't make any sense, and it would make your work a lot harder. So these are the key principles why you should use Turbosmooth. And I couldn't end up this presentation without mentioning the golden rule of modeling. Basically, it sounds a little bit like this. So you should always try to model everything in quads. A quad being a 4-sided polygon or a square. Basically, because if you model something and have triangles or n-gons in it, an n-gon being a pentagon, a hexagon, octagon, whatever, which is anything that is not 4-sided, you might end up with undesired bumps, creases, dents, and whatsoever when you smooth it. Basically, quads will give you a nice, smooth, desirable, and predictable result as opposed to n-gons because of the way smoothing algorithm works. So now that we're done with this presentation, now that you know how the technical stuff works, let's move on to 3ds Max, and I'll show you how to actually use it. So here I am in 3ds Max, and I'm gonna show you an example of where I showed you what happens with a box when you don't really have that many iterations in it. So let's create a cube, and I'm gonna use a cube with just one segment on each side. Okay, and let's give it a little bit different color. There we go. I work with blue wireframes, so this might look a little bit different with your setup. And let's add a Turbosmooth modifier. And instantly, even with one iteration, you can see that this cube has actually been transformed into a ball. If I give it more segments there, you can see that it's actually been transformed into a sphere. So this is what happens when you don't think ahead when modeling. Like I said, you cannot just simply go and apply Turbosmooth to whatever you're modeling, because you will most likely not get the desired effects. Okay, so for example, if you take a cylinder there, okay, this cylinder. And if you apply Turbosmooth on a cylinder, see what happens. You actually get these kind of weird bumps there. And these bumps are again due to the fact that we're actually having a non-quad here, which is an 18-sided polygon here. See? So this gives us these weird bumps and stuff, just like I said in the presentation. So how do we work this out? How do we actually create a model in a fashion so that Turbosmooth will know what to do with it and give us nice predictable results? Basically, like I showed you, you have to add additional geometry to appeal the smoothing algorithm, okay? So basically, I have a box there, and I'm gonna add an edit poly modifier, okay? And I'm gonna select all these edges. You can select them the old-fashioned way, or you can get fancy and select just one edge and say ring, which selects all the perpendicular edges, okay? So this is it, and we're gonna use a command called connect. We're gonna open the dialog box, and we're gonna use two segments, and we're gonna pinch them out, say 96% of the way, okay? I'm gonna say okay, and I'm gonna do the same thing over there. And now you don't have to open up the dialog, you can just click the button because it remembers the settings you used the last time. And I'm also gonna do this right here. Okay, so what we have now is a tighter edge around there. We of course end up with more geometry, more edges, more polygons, but this will make the Turbosmooth work the way we would expect it to. Basically now, if we look closely over there, what Turbosmooth will actually do is not go around and interpolate all this all the way from one edge to another. It will actually interpolate the edge from roughly, I'm not saying that it will, but it roughly will interpolate from this vertex here up to this vertex right there. So we will end up with a round corner, but the cube will still remain a cube. So we've got the theory all set up. So let's see how it actually works. And that's Turbosmooth. Let's add more iterations. I use isoline display to get rid of all this messy view because it gets harder on your eyes. So basically, like I told you, we're getting a really nice crisp edge there. Let's add more. There we go. See, what we have here is a nice high poly cube, and as you can now see, the edges of this cube actually catch highlights. This is what happens in real world. This is what makes your objects look that much more realistic, as opposed to this. See, this looks like a drawing. It doesn't really look realistic, and when we apply it, yeah, just catch highlights, and this looks that much more better. Okay, so I've showed you how to use it with a cube. However, a cylinder is an entirely different story. Okay, so let's add a cylinder. There we go. Here's a cylinder. If you remember, what Turbosmooth did, it actually gave us these ugly dents here, which actually is not what we want. Okay, so I'm gonna fix that again with edit poly and adding more edge definition to the model. One way you can do it is again using connect, or if if you have max 2010 and up, you can use Swift loops right here. I'm gonna add 2 loops on the top and the bottom. Okay. You can do this with Connect. It's the old-fashioned way, but for this example it's gonna be faster because I don't need the same precision as I needed with the cube. Okay, so we have it right there, and watch what happens when I turn on the Turbosmooth. As you can see, it actually gives me a lot better definition of that edge. Also can increase the segments. It's a lot better, but it's not all the way there. I can still see dents there, because if you look at the wireframe, this is what happens. You actually get those little star patterns there all the way through. So again, let's remember the golden rule of thumb. When modeling, you actually have to model in quads. These are all quads, okay? These are 4-sided ones. This is not. This is actually an 18-sided polygon. So what I'm going to do is I'm going to select this and I'm going to say inset. And I'm going to inset it a little bit to keep that sharp edge there. Say like this. And I'm going to inset a little bit again. Okay. So basically where I need that sharp edge to appear, I have quads, which will give me predictable results. Now I'm having a flat edge. I'm gonna have a flat surface here, so it doesn't really matter if I have an 18-sided polygon here. This is really not relevant on flat surfaces, but if this surface had to be deformed, I would highly recommend cutting it up into quads and then deforming it. But on straight surfaces, for example barrels or whatever, you can get away with keeping these cylinder polygons intact and unmodified. So let's add the Turbosmooth again. As you can see now, we're getting a perfectly nice edge, which again catches highlights really nicely. This is some advanced stuff. Of course, it will increase your poly count insanely. As you can see, the old one was 164 polys and this smooth one is 87,000 polys. Well, of course you can control that with iterations. Say only 2 is okay, 2 or 3 is okay most of the time. It will look okay when rendered. I usually use 3, so it's not that bad actually, but compared to this, it is much better, right? And you can see all those little kind of starry patterns that we get there, and see how smooth and perfect this is. Okay, so basically I'm gonna show you a little bit more how to model and get away with this. Say you need to make a handle for this. Okay, say it's gonna be a cap or whatever. So basically I'm gonna select this polygon and I'm gonna extrude it like so. Okay, so I'm gonna apply the Turbosmooth again, see what happens. Even though we fixed that edge, we're still getting screwed up in here. Okay, so why is that? Well, basically because again, the Turbosmooth algorithm has to interpolate from this point up to this point and up to this point, which results in what we saw, right? See? So if you're modeling something and you need sharp edges somewhere, you're gonna have to add more loops, like so, again like so, and I'm gonna use this polygon right here, and I'm gonna again inset it and inset it. Okay, so watch what happens now. We're getting that nice perfect edge here and there. Okay, so this is the way I actually modeled my revolver. this is actually the way I model everything. Hard surface modelers have to think ahead when modeling anything, where they're gonna add all those loops and what's gonna happen when they do, because for example, if I added another loop where it's not supposed to be, say I'm gonna add a loop here, for some reason I'm just gonna add a loop here. Okay, so say you were smoothing some place there and you actually ended up adding a loop all the way through. What will happen is you'll get a sharp edge all the way. So when modeling with Turbosmooth and adding loops, you have to look out for where you add them and what is going to happen next. Okay, and if you, for example, add too many loops, say I'm going to add another one there. Again, look what happens. We're getting a sharp edge there instead of a cylinder. So be careful when doing that. This is not something I'm gonna explain to you in detail because it naturally comes from experience. The more you model, the more you understand how the things work. But basically, I tried to explain the basic technical stuff behind this so you know how it works and you can think ahead and actually think of how to get away in certain situation. So this is pretty much it for this lesson, and I'm gonna roughly show you my revolver model and how turbo smoothing actually affects the appearance of it. Okay, this is the model, and I usually use Turbosmooth with it, right? So it looks that good. And let's open it up. So see how good it looks. See how these edges here catch highlights. These here catch highlights. This here catches highlights. These here catch highlights. Okay. And if I turn the Turbosmooth off, this is what actually happens. This becomes very squarey and blocky and all that stuff. Okay. This is the way I actually model it. I just model it in the fashion because I knew I would get nice smooth angle here, but I wanted to make everything else sharp. Okay, I wanted to make this sharp, I wanted to make all this face sharp, I wanted to make all these circles sharp. These are actually just hexagon shapes. Okay, these are nowhere near circly. You can get a circle from a hexagon, a pentagon, a square. This is what happens when you turbo smooth it. Okay, so when modeling, just try to think ahead. Okay, for example, in these here shapes, I wanted a sharp edge there, and this is why I added this loop, and I'm actually getting a nice sharp edge there. Okay, this is the way I modeled it, and with experience, you will also see that you'll be able to do this, stuff exactly like this, which looks photorealistic, and you know, that much more accurate than what anyone else could do. So there we go. This is the presentation on turbo smoothing, and hopefully it helps you understand a little bit more about modeling and how I do things. So thank you for watching, and see you next time.